this topic in mathematics, that is circle geometry. Now, we need to define what a circle is. So, what is a circle? When you hear circle, a circle is a locus of a point, locus of points equidistant, equidistant, equidistant from a fixed point. So that's what a circle is. So when we demonstrate it here, we have a fixed point. Let's say that's point O. It's a distance r. So this locus of a point moving with this fixed distance, with this distance from this fixed point, is what we refer to as a circle. So a circle is locus of points equidistant from a fixed point. Then we can define some part of a circle, like number one, we have circumference of a circle. We have a radius. We have diameter. We have chord. We have arc. We have sector. We have segments. So these are part of the circle you need to be familiar with. Then let's look at this part of the circle one after the other. When we say circumference is a distance around the circle. You have a circle like this. This distance around the circle, we have circle center O. The distance around this circle here is what is called as circumference. Okay, now what is radius? A radius is a line that is drawn from the center of a circle to any part of the circle. So draw a line from the center to any part here. So this line is what is referred to as radius. So just from the center to any part. So if you draw it this way as well, this is also a radius. All right. Okay. Now, what is a diameter? A diameter is a line drawn from the center of a circle and touching the circumference at both sides, at two sides. So it's a straight line. When you hear diameter, is a straight line that pass through the center of a circle. We can make this radius here to be straight line here, which means that it's as if we draw another radius here, which is line with this other radius. So now this line that touch the circle at both sides and pass through the center is called diameter. So from here to here is also a radius. So we can refer to diameter as 2 radius. Diameter is 2 radius. Then let's look at a chord. A chord is a line that touches the circumference at 2 points. For instance, when we have this line drawn, you can say this is line called AB. This is a chord. It touches the circumference at both sides. So we have this as a chord. We can see that also this diameter is also a chord because it's also touching the circumference of both sides. So it's also a chord. That is why diameter is the longest chord of a circle. So we have a chord, also an arc. What is an arc? An arc is a part of the circumference. When we cut any part of the circumference, that's an arc. Remember, this is circumference. So if you cut, say you cut here to this place, so becoming something like this. So we call this arc. This distance, if I call this is C, this is D. From C to point D is an arc. All right. So that is that. And what is a sector? A sector is a region that is surrounded by two radii and an arc. Just like we have it here, we have the CO here is a radius, DO here is a radius, and CD here is an arc. So this region here bounded by those two radii and an arc is what is called a sector. That's a sector of a circle. And in this circle now, that sector we shaded is a smaller sector. And we can also call it minor sector. And the other one here that is not shaded, which looks like this, is also a sector, but it's a major sector here. Sorry. So this is also a sector when you look at it. And this here we refer to it as a major sector. Okay? Because why? It is also bounded by two radii and this arc CD. We call it also major arc because when you cut off an arc, one is small and the other is large. So the smaller one is called minor arc. The major one is called major arc. So a minor arc will form a minor sector. Why a major arc will form a major sector? I believe you are enjoying this class. So give a thumbs up, share this video, and also subscribe if you are joining for the first time. All right. Now that's a sector. What's a segment? A segment is a region that is bounded by a chord, like we have this chord AB and an arc. So we have this arc AB as well, which is a minor arc here. So this region here is what is called segments. And when you look at it, it's bounded by a chord, this chord and this arc. So we call it segment. And the smaller segment here is also a minor segment. The other one too, when we clean everything inside here, this other bigger one is also a segment. We call it a major segment. Okay. Then let's now look at, before we look at theorem, circle theorem, look at some lemma before theorem. We call it lemma. We have the first one we are looking at is a circle with center O, a circle with center O, which has a chord. We have a circle, center O, and we have a chord. Let's label this chord as AB. Or you might say a circle with center O, and we have an arc AB. So when we talk about circle theorem, we can use either a chord or an arc. So both serve the same function. We have a circle center O with a chord AB or an arc AB. Now, this first lemma is saying that a chord or an arc of a circle can subtend two angles at the center of the circle. Now, the word subtends here means form. Now, form two angles at the center. When we join this angle to this angle here, so this chord here has already formed two angles here. The one inside here and the one outside here. So we have the first angle is obtuse angle AOB. Obtuse angle is the one inside. And the second one is reflex angle AOB. The reflex angle is the one outside. Now, when is an arc, the same method. This arc subtends two angles at center here. So this angle inside here and this angle outside here. The one obtuse and the one reflex. So understanding of this lemma will help us to know that which angle is at the center that is subtended by a chord or an arc. You are watching us live at Master T Class. Thank you for connecting. Now, number two lemma, we are still considering a circle with center O with a chord. Can label it as chord AB as well, or it might be a circle with center O with an arc AB. Now, this chord and this arc can also subtend angle and circumference of the circle. That's why we know where circumference is. That's distance around the circle. So this chord now form angle at the circumference at this side. Also form angle at circumference at this side, making two angles. One is formed here. We can label it as C, D. So one, we have angle ACB, ACB, when we use three letters. And two, we have angle ADB, also this angle here. So we have two angle forms as well as circumference. Also, an arc can also do the same thing. An arc can form angle as circumference at this side. Also, angle as circumference at the other side. So we have this angle, this angle. Can label it as C and D as well. So that is that. The second thing we need to understand here. And we can as well have number three. And we say that a diameter, when we define a chord, we say a chord is a line that touches circumference of both sides. And we look at diameter. Diameter is also a chord. Why? Because it's the longest chord of the circle. It also touches the circumference of both sides, passing through the center. Now, when you look at this, we have the center of the circle, and this line drawn passing through the center, AB, is also serving as a chord and is a diameter. Okay. Now, it also subtends angle at the circumference. So when we form angle at the circumference by this diameter, this angle is 90 degrees. So it's constant. It's constant. No matter the direction of the diameter or the angle formed, that angle will be 90 degrees. So take note of that. So when we have this as a circle, then we have center O, bit like this. So far this is center O, and this line crosses it and touches the circumference. We have this line to be a diameter, and an angle is formed by the diameter no matter the side. This angle is also said to be 90 degrees. That's what we are talking about here. So